Okay, so for 4-5 day 1 function operations, we're going to combine functions by addition, subtraction, multiplication, and division, and identify the domain of the result. We're only going to do that specifically when we're dividing, because that's when the domain is something other than all real numbers. So you'll see two different types of notation. So notice that on the left-hand side here, I have f plus g inside parentheses of x. So this doesn't mean that I'm multiplying here f plus g times x. That's f plus g of x. So that means the same thing as f of x plus g of x. Same thing with subtracting. F minus g of x is the same as f of x minus g of x. F times, so that's actually multiplying, f times g of x is the same as having f of x times g of x. And then dividing f divided by g of x is the same as f of x divided by g of x. So we're going to use the notations on the right to kind of organize our work in the problems. So let's look at example 1, where we're going to do each of those. So we have two different functions. We have f of x, which is 3x plus 4, and we have g of x, which is x squared minus 5x plus 2. We're identifying the rules for the following functions. So one thing to note is that when it says identify the rules, that really means I'm going to perform the operation and I'm going to simplify. So my answer needs to be completely simplified in order for this problem to be completed. So if I have something that says f plus g, remember that means they want us to take f of x and g of x and add them together. Okay, so when I'm adding, I'm really just combining like terms. So f of x in this equation or in this problem is 3x plus 4. So f of x is 3x plus 4. G of x in this problem is x squared minus 5x plus 2. So I'm going to add x squared minus 5x plus 2 with f of x 3x plus 4. So remember, I'm just combining like terms. Notice that when I line these up, I line them up with like terms. So there was no x squared in f. So that means that our answer will have just x squared in it. And then 3x minus 5x, if I combine those like terms, is going to give me negative 2x. And then 4 plus 2 is 6. So f plus g of x is equal to x squared minus 2x plus 6. In the next problem, I'm doing something very similar, but I'm subtracting. So I want to take f of x and I want to subtract g of x. So remember that whenever I'm subtracting, I have to change the signs of g before I can combine my like terms. So if I think about this in terms of this, the only difference is that this plus sign here is going to be a minus sign. And because of that, I'm going to end up writing this in parentheses so that I can remember to change those signs. So if I have 3x plus 4, and I'm subtracting, and I'm just going to write this here quickly, my f, which was x squared minus 5x plus 2, what that really means is I'm subtracting x squared, I'm adding 5x, and I'm subtracting 2 if I change all those signs in G. So F stays the same. I still have 3x plus 4 there, but now instead of adding my x squared minus 5x plus 2, because I'm subtracting it, I want to think about that instead as negative x squared, right? I distributed this, plus 5x minus 2, so that I can think about this as an addition problem, right? So I change the signs to make it addition, and now that gives me an answer of negative x squared. 3x plus 5x is 8x. And then 4 minus 2 is positive 2. So that gives us negative x squared plus 8x plus 2. Okay, so next one, we're going to do the opposite. We're going to do g minus x. So we're going to take our equation for g of x and we're going to subtract our equation for f of x. So it's backwards from what we just did. So g of x is our x squared minus 5x plus 2. We're going to subtract our f of x, which was the equation 3x plus 4. Just like we did in the last one, remember this tells us we need to change our signs. So that means that this turns into, we're going to add negative 3x minus 4 instead of subtracting, right? So subtracting we're thinking about as adding the opposite. So we're keeping g of x as it was written. And then we're going to add the opposite of f of x to that, right? So we change 3x plus 4 into negative 3x minus 4. If I add those together, I get x squared minus 8x minus 2. So notice it's the opposite of what we got in B when the order was backwards. So then the last one we're doing is f times g. So f times g is telling us that they want us to take our equation for f of x and multiply that times our equation for g of x. So the equation for f of x was our 3x plus 4 times the equation for g of x was x squared minus 5x plus 2. And we're going to multiply those together. So remember that means that I need to take the 3x and I need to distribute it to each term in g of x. So if I do that, 3x times x squared gives us 3x to the third power. Then 3x times negative 5x gives us negative 15x to the second power. And then 3x times 2 gives us plus 6x. We're going to do the same thing with the 4. We have to distribute the 4 to all three terms here. So 4 times x squared is going to give us 4x squared. I'm going to write that underneath our previous x squared term. And then 4 times negative 5x is negative 20x. And finally, 4 times 2 is plus 8. So if we combine those like terms, we have 3x cubed minus 11x squared minus 14x plus 8. Okay, so that's adding, subtracting, and multiplying. There's a try it on the student companion page 98 if we want to do that, where we're adding and subtracting. And then let's look at example 2. So for example 2, we've got a modeling problem. So the demand D in units sold for a company's new brand of cell phone at price X in dollars is, so D of X is 5,000 minus 10X. That's a typo. So there shouldn't be a minus here. It should just be 5,000 minus 10X. We can see that there. So what is the company's expected revenue from cell phone sales in terms of price X? So our price is P of X, that's the number X. And the demand function is D of X equals 5,000 minus 10X. And revenue, capital R of X, is the price times the demand. Okay, so revenue is price times demand. So they want us to find the expected revenue. So they want us to find R of X if we know P of X and we know D of X. So we know the demand and we know the price. So the price is just X times the demand is that 5,000 minus 10x. So we're going to do x times 5,000 minus 10x. So what this means is that we're really just distributing that x. So the revenue is going to be equal to 5,000x minus 10x squared. Okay, so the function to find the revenue for the company is 5,000 times x minus 10x squared. Okay, so there is a practice problem on student companion page 98, number 2, if we want to do that one as well. Okay, so for example 3, we are going to divide. So this one is separate from the adding and subtracting and multiplying because this is where we have to identify the domain. So with adding and subtracting and multiplying, the domain is not restricted. I can use all numbers of x that work in the function. Versus when I'm dividing, I've created an indication where I can't divide by a 0. So I have to take and identify the values that will make my denominator 0, or whatever function is on the bottom 0, in order to eliminate those from my domain so that I can have a real number answer. So when I'm doing division, so in this case, I'm doing f over g. So that's telling me I want to take f of x and I want to write it over g of x. And I want to simplify. So remember that whenever we see the identify the rule, that means we need to simplify our answers, which if I'm dividing usually means I'm going to be able to eliminate something. I'm going to be able to reduce. Okay, so my f is x minus 7. So I've got x minus 7 over my g is 2x squared minus 13x minus 7. 2x squared minus 13x minus 7. And so when I'm doing this, because I have to simplify, you want to factor any quadratics you can. In our case, g of x is a quadratic. And so we have to see, can we factor g of x so that something may reduce? So remember that when I'm factoring g of x, I'm going to multiply a times c and see what factors of a times c add to b. So if a is 2 and c is -7, a times c is -14 and b is -13. So remember the process that you're going through here is you're factoring 14. So 1 and 14, 2 and 7 are the only factors of 14. Because it's negative product, I know one of these has to be negative. I look over here to tell which one. So since they have to add to a negative number, that tells me that the larger numbers need to be negative. So +1 times -14 makes -14. +1 plus -14 makes -13 versus 2 plus -7 makes -5. So I can split this as a 1 minus 14. Remember, because a is not 1, I have to use grouping. So I have to write 2x squared, and I'm splitting up my -13x with these numbers. So I have +1x minus 14x, and then I'm keeping my c term -7. So remember that we're finding these numbers to eliminate our b and go backwards to find the factors. So if I draw a line to create two groups, notice that I only have an x as my GCF for the first two terms. So that means if I factor out x, I'm left with 2x plus 1. The second pair of terms have a -7 as their common factor. And if I divide both of these by -7, I get a +2x and a +1. So that means that my factors of g of x are 2x plus 1 and x minus 7. So my common binomial factor 2x plus 1. The factors from the GCFs are x and minus 7. So that means that f of x was x minus 7. I can rewrite g of x, 2x squared minus 13x minus 7, as 2x plus 1 times x minus 7. Okay, so this is the point where I have to find my domain. Remember, my domain comes from that denominator. So my domain is going to be all real numbers except the values that are going to make this 0, right? So to find these values, what I'm going to do is I'm going to take these denominators, 2x plus 1. I need to figure out what's going to make that 0 because that's not allowed. I also know that x minus 7 cannot be 0 because that's not allowed. Okay, so if I solve each of these, this one's easy. This tells me x can't be positive 7. If I think about this in that same way, right, I just changed the sign here. So that tells me not x anymore, but 2x can't be negative 1. And if I were to divide those by 2, that means x cannot also be negative 1/2. Okay, so this little common error thing here is explaining that what we just did, why we did it in this step. Because notice that once we go back to our expression, I can reduce x minus 7 divided by x minus 7 is 1. So that means that we're left with 1 over 2x plus 1. Okay, so that is our answer. That's our rule. And then our domain is all real numbers except 7 and negative 1/2. Okay, so let's look at another example. So for B, f of x is x squared minus 3x minus 18. G of x is x plus 3. So f of g, they want us to find f of x over g of x. So I noticed that for this one, f of x is my quadratic. So x squared minus 3x minus 18. Remember, like the last one, if we have quadratics, we will have to factor them. G of x is x plus 3. That's linear. I cannot factor that. So I know that my denominator is just going to stay x plus 3. But because this is quadratic or x squared, right? So something, I have to do my product sum. So A is 1 times C is negative 18. So 1 times negative 18 is negative 18. So I'm going to factor negative 18. So that those factors, I'm looking for the ones that add to negative 3. So if I factor negative 18, I have a few options. I have 1 and 18, I have 2 and 9, or I have 3 and 6. Those are all the factors of negative 18 or of 18. Since my sum needs to be negative, that tells me the larger numbers need to be negative. So the pair that works is the 3 and negative 6. Remember that A was 1. That means I don't have to use grouping. I can use the shortcut. So that means that my factored form is x plus 3 and x minus 6. Okay, I was only able to do that because A was 1. Okay, so now let's look at our domain. So remember that the domain is all real numbers except the values that are going to make our denominator 0. So our denominator was only x plus 3. So if that can't be 0, that tells us that x can't be negative 3. Okay, so all real numbers except negative 3 is going to be our domain values that make this function work. Because we are not allowed to divide by 0. We can reduce because x plus 3 divided by x plus 3 is 1. So we end up with x minus 6, technically over 1. Remember, when the 1 is in the denominator, though, we can ignore it. So our answer here is just x minus 6. Okay, so just to recap, we're making our fraction using the order that they give us here. We have to factor anything that's quadratic or higher technically. We use product sum. In this case, A was 1, so we were able to use the shortcut. In the previous one, A was 2, so we had to use grouping. So that was the longer method. We find the value that would make the denominator 0, and that's excluded from our domain. So let's try one more just for good measure. This time we're going to do a different order. We have G over F. So they're asking us to find G of X over F of X. Okay, so G of X is our X minus 9. So X minus 9 is going to be our numerator. F of X is X squared minus 5X minus 36 is going to be our denominator. One thing to notice if we look back, in the first problem, the higher degree was in the denominator, so our answer stayed a fraction. In the second one, the higher degree was in the numerator, so our answer was no longer a fraction, right? Our denominator went away. And so in this one, notice that the higher degree is in the denominator, so we should end up with 1 over something again. Okay, so remember that we're looking at our quadratic and seeing if we can factor it. Notice that A is 1, so this is going to be the nice one where I know it's going to be X times something and X times something else when I factor that numerator. So if I multiply A times C, 1 times negative 36, I'm looking for the factors of negative 36. I specifically want the factors that add up to negative 5. Okay, so if I look at these factors of 36, I've got 1 and 36, 2 and 18, 3 and 12. And notice, even if I make one of these negative, I'm still got too big of numbers here. So that's already 9. So I'm getting closer. So then 4 and negative 9, that one's going to work, right? 4 minus 9 is negative 5. So again, because A was 1, I'm able to know that X and X are my first terms in my factors. And then the numbers from the product sum are the second terms in my factors. So I've got X plus 4 and X minus 9. If I look at the domain, remember that it's going to be all real numbers except those values that are going to make my denominator 0. So I've got X plus 4 can't be 0. And I've got that X minus 9 can't be 0. So that means that X cannot be a negative 4 or a positive 9. So it's all real numbers except negative 4 and positive 9. And I have to do that in that step again, remember, because this X minus 9 reduces. So X minus 9 divided by X minus 9 is 1. So I'm left with 1 over X plus 4. Okay, so that is dividing. Remember, in dividing, we're looking for the domain restriction, the values that will make the denominator 0. There is a practice problem on page 98 in your student companion number 3 if we would like to do that.